Alright, now with this paper that we're going to do, we have multi-step equations we're going to be solving, and these are basically, many of them are going to be two-step equations, what we would normally see as a two-step equation, but with a variable on both sides. So we're going to get some practice doing these types of multi-step equations, and what I'm going to do is I'm going to work out the odd numbers, and then I want you to work out the even numbers. So just follow along, and we'll start with number 1. So with number 1, notice that we have negative 4x and negative 6x is equal to negative 20. So this is where we're going to pull together our two-step equations and our knowledge of combining like terms, because we should recognize that this term, negative 4x, and this term, negative 6x, are alike, and we can add them together. So I'm going to draw an arrow there. If we put these two together, we have negative 4x minus 6x, so we're going to put those together, and it's going to be negative 10x is equal to negative 20. Now we just got to do our final step. We still got to get x by itself. So the opposite operation, or our inverse operation, of multiplying 10 to x is dividing x by negative 10. Remember, what we do to one side of the equation, we have to do it to the other. So that'll go into that one time. That's just going to leave me with x. And now I'm going to do my left side of the equation, which is negative 20 divided by negative 10. And that's going to be a positive 2. Because negative 20 divided by negative 10 will go 2 times. And a negative divided by a negative is a positive. And there's your answer. Alright, we're going to go ahead and look at our next one. And that's question number 3. So what we have is we have 8x minus 2 equals negative 9 plus 7x. So notice in this case we actually have a variable on both sides of the equation. And so what we got to do is we're going to go ahead and have to rearrange a couple different things. We're going to start just like before. We're going to start by subtracting and adding terms so that we can rearrange this to get all the x's on one side and get the constants on the other side. Now what I like to do, you always want your variable to be positive. Notice this x is positive. In every problem we've done so far, the variable must be positive. So with that being said, I want to move my 7 over to this side, because if I subtract 7x from 8x, it leaves me with a positive x value. So I'm going to go ahead and do that. Negative 7x. Negative 7x. Now that's going to get rid of this. This is now going to be 0, and this right here, if I add that, that's going to combine those two terms, right? Put them together, that's going to give me a positive 1x. And I don't have to write the 1 in front. Just if I have 1x, we understand that there's an implied 1 in front, and this just means 1x. Now I need to move my 2 over to the other side of the equal sign. So I'm going to add 2. I'm going to add 2. Negative 2 and positive 2 is 0. Cross those out. And negative 9 and positive 2, if I add that up, put it together and bring it down, that's going to give me a negative 7. And now I have nothing else to do. That problem is solved. So x is equal to negative 7. Alright, number 5. I have 4m minus 4 equals 4m. So notice that I have a variable on both sides of the equal sign in this equation. So what I need to do is I need to isolate m. And so how I'm going to start, because there's only a constant on this side, I'm going to go ahead and subtract this 4m and move it over. And that gets my constant separated from my variable. So if I subtract 4m here, I have to balance out the equation by doing the same on this side. And what I ended up with is 4 minus 4m. That's 0. I bring down my negative 4. And then I have 4m minus 4m. That gives me 0 again. So now I run into a problem. Notice I have a statement that says negative 4 is equal to 0. And you got to ask yourself, is that true? Is negative 4 the same thing as 0? Is owing somebody $4 the same thing as owing them $0? And I think you'll realize that this is an untrue statement. And anytime we have an untrue statement, our answer is going to be no solution. That's one of our vocabulary words that we went over in our Cornell notes on this. And when you see that no solution, What it means is it doesn't matter what number we plug in for this variable m, it's always going to show an untrue statement. So because there is no number that will ever make this equation true, there is no solution to the problem. Alright, we're going to go ahead and do number 7. And number 7, we have 5p minus 14 is equal to 8p plus 4. Notice that we have a p on both sides, and we have constants on both sides, 14 and 4. So what I want to do is I want to keep my p positive. I just think it's easier if you do it this way, and you don't have to. It's your choice. You can actually wait and divide out a negative number from p later, but I think it's easier just to keep it positive. So what I'm going to do is I'm actually going to subtract my 5p from over here, and then to balance my equation, I'm going to subtract it from this side as well. And then I'm going to move my 4 over to the left side. So I'm going to subtract my 4 from here, and I'm going to subtract 4 from here. So now we just got to work it out. 5p minus 5p is 0. Negative 14 minus 14 gives me negative 18. And 8p minus 5p is going to give me 3p. And 4 minus 4 is going to give me 0. So those just cancel out. So now I have negative 18 is equal to 3p. Well, I still want to get p by itself. So I need to move this coefficient. I need to move it over to the other side of the equation. So I just need to do the inverse operation. And the inverse operation of multiplying 3 to p is dividing by 3. So I'm going to do it to this side as well to balance it out. So 3 are going to 3 one time. That just leaves me with p. And p is equal to 3 are going to 18, negative 18, 6 times. And it's going to be negative 6. And that is my answer. So let's do number 9. Number 9 is negative 8 is equal to minus, and then we have parenthesis, x plus 4. So in this one, we're going to have a couple steps we have to do. Anytime we have parentheses, remember PEMDAS, we do need to do what's inside these parentheses first before trying to move anything over. So the first thing we need to do is get rid of this negative sign. And what I want you to think about is anytime we have a negative sign in front of a parenthesis, there's always an implied 1 before that parenthesis. So negative parenthesis x plus 4 is really the same thing as negative 1 parenthesis x plus 4. So we practiced during combining our like terms, distributing a number when we have parentheses. So we're going to do the same thing. We're going to distribute this 1. Let me go and bring down that negative 8. So if I say negative 1 times x, that's going to give me a negative x. And negative 1 times 4 is going to give me a negative 4. Equals negative 8. So now what I want to do is move this constant to the other side of the equation and combine it with the other constant. So we're subtracting 4, so inverse operation would mean that we add 4 to both sides. That gives me 0 right there. And then negative 4 plus 4 is going to give me negative 4, and that's going to be equal to a negative x. Now we still have one more problem. Remember I told you that in our final answer, our variable cannot be negative. It must be positive. So in this case, what we can do is we can divide. We know there's an implied 1 in front of our x because this is 1x. We can actually divide it by negative 1, divide this by negative 1, and then it would give us our answer. I'm going to write that answer right up here. So, negative 1 divided by negative 1 is just going to leave us with x. And negative 4 divided by negative 1 is just going to leave us with a positive 4. And that is our answer. Alright, on this one right here, what we have is problem 11. In problem 11, we have 14 minus a parenthesis, p minus 8, close parenthesis. So when we have that, we're having the same type of issue we had with number 9. So with that being said, let's go ahead and distribute this negative 1 over. So I have negative 1 times p. That's going to give me a negative p. Negative 1 times negative 8 is going to give me a positive 8. And then I just bring down my 14. So now I want to get this constant 8 over here on this side of the equation and combine it. So I'm going to subtract 8 from both sides to balance my equation. That gets rid of those two. And 14 minus 8 is going to be 6. And I have a negative p. So here we are in the same predicament. We have negative p is equal to 6. And I'm going to rewrite that over here. Negative p is equal to 6. And we need to get rid of that negative sign. So remember, there's always an implied 1 in front of the letter. So we're going to divide it by negative 1. And that cancels out our negative sign. And we'll divide this by negative 1. And that's going to give us a negative 6. So therefore p is equal to negative 6. And that is our answer. Alright, so here's our next problem. Problem number 13. And looking at it, it looks like it's just a lot more complicated than the other ones we were doing. But we're going to follow our same steps that we've been doing with distributing and then moving our terms around. And we're going to be able to solve it. So let's take a look. We have negative 18 minus 6k equals 6, parenthesis, 1 plus 3k, close parenthesis. So let's go ahead and start off by distributing this 6. So we'll do 6 times 1, that gives me a positive 6. 6 times 3k, all I'm going to do is multiply the coefficients. I'm going to multiply 6 times that 3, that gives me 18, and then I know k comes after it. So it's going to be plus 18k. And that's equal to negative 18 minus 6k. Alright, so now that we're here, we need to go ahead and try to get k by itself. So what I'm going to do is I'm going to add, or let's see, I'm going to add my 6k to both sides because I want to keep my variable positive. That cancels those out. And then I'm going to subtract 6 from both sides. Cancels those out. So I have negative 18 and negative 6. That gives me a negative 24 is equal to 24k. Alright. So now that we got 24k is equal to negative 24k, we just have to go ahead and do our division. So we have 24k. The opposite of multiplying k by 24 is dividing k by 24. And we're going to divide this one by 24 as well. So 24 going to 24 one time. I'm going to write the answer over here. That leaves us with k is equal to, and negative 24 divided by 24 will go negative 1 times. And that is our answer. K is equal to negative 1. Alright, I'm going to go ahead and go to the next problem, problem 15. We have 2 times 4x minus 3 minus 8 equals 4 plus 2x. So just like before, the first thing that we need to do is we need to be distributing this value before the parenthesis. So 2 times 4 is 8. So that's going to give me 8x. And 2 times negative 3 is going to be negative 6. I'll bring down my negative 8. And that's equal to 4 plus 2x. Now, in this case, there's actually something we can do before rearranging anything. We can actually combine these two like terms, negative 6 and negative 8. So let's combine those. And negative 6 with negative 8, if we combine those, that's going to give me a negative 14. And we have 8x equals 4 plus 2x. So now that we got this, we can go ahead and start moving our variable and moving our constant so we can get x by itself. So I'm going to rewrite this right up here so I have more room to work. Now, what I'm going to do is subtract 2x from both sides. And then I'm going to move my 14 over here by adding 14 to both sides. And that gets rid of my 14. This gets rid of my 2. So if I have 8x minus 2x, it gives me 6x is equal to, and then I have 4 plus 14, and that's going to give me 18. Now I need to do my final step to get x by itself and do the opposite of multiplying 6 to x, which is dividing x by 6. And I have to do it to both sides to balance my equation. And that gives me x is equal to 6 going 18 3 times. And there is my answer. And now we are almost done. So let's go on and do 17 and see what we come up with. I have a negative 1 times 1. It's going to give me negative 1. Negative 1 times 7x gives me negative 7x. Negative 6 times negative 7 is going to give me a positive 42. And negative 6 times negative x is going to give me a positive 6x. And that's all equal to 36. So now that we've done this, let's go ahead and try to combine anything that we can combine. And I recognize that I can combine my negative 1 and my positive 42. So if I combine those, negative 1 and 42 combined, and I'll draw like a little arrow so you can see, is going to be 41. And then I can combine my negative 7x and my positive 6x. So if I combine those two, negative 7 and positive 6 gives me a negative 1x. And that's all equal to 36. So now that I got 41 minus x equals 36, I need to go ahead and I'm going to move it over here so we got room to do some more work. 41 minus x equals 36. I need to move this constant over here. So I'm going to subtract it from both sides. That leaves me with negative x equals, and if I subtract this, I'll end up with negative 5. And now I need to go ahead and divide out negative 1 to get rid of this negative sign. Divide that by negative 1. That crosses those out. Leaves me with x is equal to positive 5. Alright, my final practice problem. So, number 19. What we need to do is first distribute this negative 4. So I'll do negative 4 times 1. That gives me negative 4. Negative 4 times negative 6a. That's going to give me a positive 24a. And then that's equal to negative 22. Bring down my 24a. And now we can start trying to move things across this equal sign right here. Alright. So, what I would do at this point is go ahead and subtract 24a from both sides. And then add 4 to both sides. That gets rid of that, gets rid of that. Then I have negative 22 plus 4 gives me negative 18. And 24 minus 24, well, that gives me 0. And here we are, we have a statement. Negative 18 is equal to 0. So that's saying if you owe somebody $18, it's the same as you owe them nothing. And we all know that's not a true statement. Because it's not a true statement, there is no solution. Alright, now it's up to you to go ahead and complete 2 through 20 on your own. Do the best that you can. And raise your hand if you have any questions and I'll answer it.